Hey guys, so today we are going to be on the back of the Proving Trigonometric Identities notes. Um, so today we're only going to be going over number 7 and number 8. 8's going to be a little bit more involved, so we'll spend a little bit of time on that one. We're going to do things a little bit differently today. Along with this video, I'm going to post a short problem set that uses yesterday and today's notes, probably 3 questions or so. And using that, I want you to just show me that you're following along here, attempt each problem and send it to me. You are encouraged, if you have any questions about the problem sets or about the notes in general, anything at all, please reach out over Teams so I can answer everyone's questions for you. All right, so let's take a look at number 7 to start with. So yesterday we talked about when you're proving trigonometric identities, the first thing you want to do is identify the more complicated side. I think we can agree that the more complicated side here is that one right there. So what we're going to be doing is simplifying that side. And we know that when it's simplified, I should end up with 1 plus sine squared theta. So let's see if this works. Now, there's a couple different ways to go about this. If you look at your answer key, they're actually going to do it a different way than I did. And that's fine. You can do it that way. I feel like my way is a little bit simpler, but whatever works for you. So let's get started. Let's simplify this side. So let's first identify where is there any identities here. 1 plus cosecant is actually not an identity. 1 plus cotangent is. And if I subtract 1, that's cosecant minus 1, but there is no 1 plus cosecant over here. So I can't use that as an identity. But if you look at the bottom, 1 plus cotangent is an identity, and that equals cosecant squared theta. So the first thing I'm going to do is just change this to say 1 plus cosecant squared theta over cosecant squared theta. Now, there's 2 ways to get from here to the next spot, okay? The easiest way I've found is going to be split it up. Put this over cosecant, and then put cosecant over cosecant. So 1 over cosecant squared theta minus cosecant squared theta over cosecant squared theta. Well, these reduce to 1, right? So it is 1 over cosecant squared theta minus 1. And what is 1 over cosecant squared theta? Well, that's sine. So the answer is sine. Oh, this was a plus up here. I messed it. So this should be plus sine squared theta plus 1, which, as you probably notice, is the same as that. So get all that down. That one was a little bit shorter, a little bit simpler than the one we're about to do here, because the next one you're going to see actually does not have shortcuts like that. So let's take a look at the next one. The complicated side is this one. So this is the one that I want to simplify. So let's think about some first steps. Well, those are not squared. It's not secant squared u plus cosecant squared u. So these are not identities because they're not squared. You can't use Pythagorean identities unless they're squared functions, which those are not. So really all we're left with here, and you can't, if there's more than one thing on the bottom, you can't split it up. So we can't do the trick we just did. But what we can do is revert back to kind of the most basic thing, which is turning everything into sine and cos. So we're going to get a pretty complicated fraction here, but let's see what we get. So secant is 1 over cos u plus cosecant is 1 over sine u. What about tangent? Well, tangent, you can see over here, is sine u over cos u. And plus cotangent is cos u over sine u. So now we've got these fractions within fractions within fractions. Whenever I have this, we need to make a common denominator for each thing. And that common denominator is going to be cos u and sine u. So let's think about what we're going to get here. So we have to put a sine u here, so we also have to put one on the top, right? We have to put a cos u here, so we also have to put one on the top. Down here, same idea. Sine u here, so there's also a sine u on the top. Cos u, so there's also a cos u on the top. Okay, so let's do all the work here. And like I said, we are not going to be doing number 9, so let's use that space to do this. So what I have here, on the top, I have sine u plus cos u all over the same denominator, which is sine u cos u, over the whole fraction. Now, sine u times sine u is sine squared u plus cos squared u all over sine u cos u. Now remember, in a fraction within a fraction, if the denominators are the same, you can flip, you keep the top, change it to multiplication, and flip the bottom. Right? And think about what happens when we do that. These go away. So another way to think about it is you could have just canceled the denominators here. So what's left? Sine u cos u plus cos u over sine squared u plus cos squared u. And what is this bottom here? That's a Pythagorean identity. It's this one right here. So that just equals 1. Sine u plus cos u over 1 is just sine u plus cos u, which is, if you remember, what we were trying to get. So those are the last two examples that we're gonna talk about with these proven. We're gonna move on to the next set of notes after this. So keep in mind that along with this post will be a short problem set with probably 3 problems or so that I want you to turn in by tomorrow at midnight. So if you have any questions, let me know. Thank you very much.